For the last problem on worksheet 2.5, we have angle ABD and CBD are right angles, and angles 2 and 4 are congruent. Those are your givens, so we have those first here, and on the second line that would be the reason why would be given. Our goal is to show that 1 and 3 are equal. First, because we have that those are right angles, we know that they're each equal to 90, and that's your definition of right angle. Since they're both equal to the same thing, they're equal to each other by the transitive property. Then I changed angle ABD into angle 1 plus angle 2. That's how I got to the next line, and the same thing happened with angle 3 and angle 4. Those were the whole angle CDB. So to figure out like how I did that or why that is the way it is, what I'm thinking is I took the whole angle and I broke it into the sum of two smaller angles. So I'm looking at adding angles together, which is the angle addition postulate. To go from this line here to the next line, the only thing that's different is that this angle 2 is no longer in the equation. It's just an angle 4. So what allowed me to take out this angle 2 and replace it with angle 4 is the substitution property. And I can do that because 2 and 4 are equal to each other, which is why I have this line here. So this given we didn't actually use until the end of the proof. My goal is to show that 1 and 3 are equal, which I'm pretty close because I have a 1 on the left side of the equal sign and a 3 on the right side of the equal sign. The only thing that I have is this plus 4 on each side. So I need to get rid of it, and the opposite of adding is subtraction. So if I subtract angle 4 on each side, that is how I'm left with angle 1 and 3 being equal to each other, because those angle 4s would cancel out on each side. One thing that you should note or notice is these three lines here is the proof for theorem 2.4, which says all right angles are congruent. So if we wanted to, we could have taken out these lines here and just put angle ABD is congruent to CBD by theorem 2.4. That was the only theorem in section 2.5 that I said that we would use, and that's because it allows you to shortcut it. But if you're not, like if you don't remember what it is, you can still prove it the original way. Your proof will just end up being a little bit longer.